So we're going to start this session. We'll reclaim a few minutes very, very slowly, fairly from every presenter. And as already mentioned, we're going to start with Tom Hardwick from many, many places, currently from Australia.
Okay, good morning, everybody. So thank you very much for the opportunity to share this work with you today. So we have no specific funding for this research. All of the authors declare no conflicts of interest, aside from Mario Malichki, who is a co-editor-in-chief of the journal Research Integrity and Peer Review. So journals might try to counter the misuse, misreporting, and misinterpretation of statistics by providing written guidance to authors on their websites. But currently there's relatively little systematic data that describes the extent and type of guidance that journals might provide. This is especially interesting in the context of controversial statistical topics. So recently, for example, some journals have introduced bans on the use of p-values. Some previous studies have sought to describe journal-based statistical guidance, but these have been limited to just a few statistical topics or have focused exclusively on medical journals. So we built on this prior work by assessing the nature and prevalence of statistical guidance by top-ranked journals across 22 scientific disciplines. So we extracted and classified in duplicate statistical guidance from the websites of 15 journals top ranked by impact factor in each of 22 scientific disciplines. So that's 330 journals in total. And any coding disagreements are resolved through discussion and arbitrated by a third coder if necessary. And we recorded whether each journal provided any statistical guidance at all, whether they had a dedicated statistical guidance section in their instructions to authors, and whether they referred to guidance in external sources such as reporting guidelines. And we recorded also whether the guidance addressed each of 20 statistical topics that we pre-specified based on pilot data. Then for 6 topics that we a priori considered to be hotly debated in the statistical literature, we classified whether journals indicated implicit or explicit opposition or endorsement. I'll elaborate a little bit more on that shortly. So on this graph, you can see the proportion of journals that provided statistical guidance in each of the 22 scientific disciplines. And the disciplines are also stratified into 5 higher level domains ordered by prevalence of statistical guidance. And the summary statistics at the domain level are in the highlighted colors. The circles here represent journals that provided any statistical guidance, and the smaller diamond shapes represent journals that had a dedicated statistical guidance section. So, for example, we have 122 of the 165, that's 74% of the health and life sciences journals providing statistical guidance. And then within that domain, you can see the discipline of clinical medicine, for example, all 15 of the assessed journals provided statistical guidance. At the other end of the spectrum, you have none of the 30 journals in the formal sciences providing statistical guidance. So overall, across all domains, there are 160 journals that provided some statistical guidance. And going beyond the graph now, 105 of these journals provided their own internal guidance as well as referring to guidance in external sources. There were 23 journals that only provided internal guidance and 32 that only referred to guidance in external sources. The external guidance consisted of 79 individual sources, 49 of which were reporting guidelines and 30 of which were various miscellaneous documents such as academic papers, textbooks, or society guidelines. And for some of the journals, which we've classified here as having internal guidance, they shared guidance at the publisher level. So this was 31 Nature journals, 12 Cell journals, and 2 Frontiers journals. So on this graph, you can see the proportion of journals that provided guidance on each of the 20 specific topics that we had pre-specified based on pilot data. And again, this is stratified by high-level domain, and you don't see the formal sciences here, of course, because none of those journals provided statistical guidance. And the topics are ordered vertically by overall frequency across the domains. So you can see that the most commonly mentioned topics, especially in the health and life sciences, were confidence intervals, p-values, sample size justification, effect sizes, and pre-specification of analyses. By contrast, the topics that received relatively little attention included sensitivity analyses, non-parametric tests, adjusting for baseline covariates, handling outliers, and categorizing continuous variables. So in this table, you can see the number of journals that offered endorsement or opposition for the 6 topics that we conceived a priori to be hotly debated and therefore potentially controversial. And I'll define each of these categories for you now. So by explicit endorsement, we meant a journal advises or instructs authors to use a particular method whenever possible or appropriate. By implicit endorsement, we mean a journal provides advice on the method, which implies endorsement, but it does not explicitly advise that the method should be used. Implicit opposition was when a journal advised that they would prefer that a method is not used, but they did not explicitly rule it out. And then finally, explicit opposition was when a journal advised that a method should not be used. So I've highlighted some particular results of interest in the table. In red, for example, you can see that there was only one journal that explicitly opposed the use of p-values. And actually, in this specific case, that was only in situations where authors had not pre-specified multiplicity correction. So it wasn't an outright p-value ban. Then in yellow, you can see that 3 journals explicitly opposed and 5 implicitly opposed the use of statistical significance testing. More commonly, as shown by the blue highlights, journals implicitly endorsed the use of p-values, statistical significance, and Bayesian statistics, and they explicitly endorsed reporting of effect sizes, confidence intervals, and sample size justifications. Sorry, the slides are a little slow to move on. In summary, we observed considerable heterogeneity in the provision of statistical guidance by 330 top-ranked journals across 22 scientific disciplines. And our study didn't explore the reasons for those differences, but potential reasons could include the extent to which statistics are being used in particular domains, the consequences of misusing statistics in those domains, and the prevalence and documentation and therefore awareness of statistical misuse in those domains, as well as the statistical competency of the typical researchers working in those domains. We observed that few journals were taking especially controversial positions, such as banning p-values. And an important limitation of the study is that we relied exclusively on journal websites. So we don't know to what extent this guidance is being enforced. We don't know whether authors are actually reading and following the guidance. And we don't know the extent to which journals provide guidance through other means, such as statistical review, which is a topic we've addressed in another study. So we hope that this mapping of statistical guidance is a useful springboard for additional research in this area. There are lots of interesting open questions to discuss. It's unclear, for example, whether journal-based statistical guidance is helpful or even potentially detrimental, especially in situations where the guidance is controversial. It's unclear if it would be better for journals to share guidance and therefore increase standardization, or whether journals developing their own guidelines is useful. It creates opportunities for experimentation, for example. And to contextualize the study as well, journals, of course, are just one leverage point in the endeavor to improve the use of statistics across the sciences. Improving statistics is likely to require some non-trivial changes to deep-rooted reward structures and educational practices. So thank you very much for your time. If you'd like to read more about the study, there's a preprint available. You can follow the link there. And I look forward to hearing your questions and comments.
Fantastic. So you already reclaimed a few minutes for your colleagues, and I see people lining up fast. So you got to the mic first. So
Hi, I'm Rashad Hayat from the Center for Reproducible Science at the University of Zurich. I have a very short question, I think. Did any of the journals endorse the inclusion of a statistician in the research team that might actually solve some of the problems?
So we didn't look at that specifically. And I'm not sure it would have been mentioned in the sections we looked at. So we were looking mainly at instructions to authors. I don't recall seeing anything like that, but it's an interesting one.
Anna?
Yeah, Anna Marušić, Croatia. Did you look into whether the journals that were in your sample were general or kind of specialized? Like, you know, you have specialty journals that may publish one type of study, so they may have kind of more specific statistical guidance, whereas for a journal that publishes all kinds of different studies, maybe, you know, then the guidance for authors would be too long to address everything. So did you look into whether your results are related to what type of journal that was?
Yes, that's a good point. So we did not look into that, and we did not classify journals by whether they were general or specialized. I'd say that probably the sample leans towards more general journals because it was these top ranked by impact factor. One aspect of the results which perhaps relates to this is that multidisciplinary journals, which are of course covering multiple areas, did tend to have very high prevalence of statistical guidance compared to other disciplines.
It would be interesting to compare it to the bottom of the ranking list.
Indeed, yeah.
In the back there. Yeah.
Thank you, Jennifer Byrne from Sydney. I was interested as to whether you looked at information about the editorial board composition and whether there was any editors that either identified statistical capacity as their area of expertise or whether journals actually had dedicated statisticians appointed to the board and whether that associated with the guidance that was provided.
Yeah, another good question. We did not address that in this study, so we just focused on guidance specifically for authors. We have actually, and worked with Steve, looked at related questions in the context of medical journals. I can't recall off the top of my head like the exact numbers of whether journals have statisticians on the board. I think it's certainly more common in medical journals than in other fields.
Right here.
Vivian Bachelet from Chile. Are you going to follow up this study with a walk the talk kind of study, looking into whether the articles that are actually published by those journals are doing what they're recommending in their statistical recommendations?
I don't have any immediate plans to do that, but there's a room full of people here. I think that's a great it's a great idea. So I do hope someone will do a similar study. Yeah.
Yes, given the number of manuscript submissions at the journals I've been involved in that don't even have page numbers, I think that would be a fantastic second step. So are there any questions from the virtual audience? Nothing.
No.
Okay. Do you want to comment a little bit more? I think it's one striking finding was the dramatic difference between medicine and other fields. What are your thoughts about that? And also, was aside from just the content, was there anything about the style with which the statistical advice was provided that was different between the different classes of journals?
Yeah, so I am somewhat speculating beyond the data here, but I think with medical journals, one of the primary reasons for providing more guidance is that, you know, if the statistics are wrong, then the consequences are pretty high compared to, for example, my own field, psychology, where you can probably get away with a lot and you're not going to cause some immediate harm.
You're going to make Ryan jump up from the front.
It's true. In addition, I think there's also much more extensive documentation of problems with statistical misuse in medicine compared to other areas. There's probably more awareness of the problem, and journals are therefore taking more steps to address it. In other areas where perhaps the meta research isn't quite developed, there might just not be awareness of the problem, and journals don't realize that's something that they can do to help.
Great, thank you very much.